Hello, this is Somesh Sharma Saravanan, currently doing my graduate studies in computer and system engineering at the University of Houston. And I'm recording this video for the purpose of my machine learning and computer vision class. And this consists of the answers for lecture recitation too. So let me go into the questions. Before that, I'd like to share my screen. So I hope my screen is visible. So this is the first question. So the question is describe how to train a classifier for more than two classes. So this is basically a multi-class classification. So first we'll go through what is multi-class classification. So it is multi-class or multinomial classification. It's just a classification where we classify instances into two or three or even more classes to be specifically. So we have more than two variables to be classified here. We can put it that way. So broadly, this can be done in many ways, but in our coursework, we have discussed about one versus all method. So I'd like to go through that, uh, which is basically like we'll be training a single classifier per class with the samples of that class as positive samples and all other samples as negative. So treating one as a positive outcome except everything. So this strategy requires the base classifier to produce a real valued confidence score for its decision rather than just a class label. So see the discrete class labels here along can lead to ambiguities where multiple class are predicted for a single sample. So I've like shared a screen for that. You could see there are like three different uh, class like there are three different classes to be classified. So when you could see h1 of x where we treat a triangle and all the other symbols as some alien value. So it's same with H2O effects where we treat square boxes of are positive and the circle ones as negative. So same with H3 effects where we treat the X mark as the positive value and all the others as negative value. So this is how we classify one versus all. And there's also another method which is like one versus one where we will have to train for more number of sets. Say if there are like k number of classes to be trained, so you'll have to train that for k into k minus 1 by 2. So these number of times we'll have to classify them. So this is the other way with which we could classify multi-class classification. So this is what I want to share for the first question. So let me stop here. Hi, now we'll be discussing about the second question. Before that, I'll share my screen. So I hope my screen is visible. So let me go to the question. So the question is, what is a learning curve for? So the question is like, what is a learning curve used for? So I take it in that way. Before that, I like give a small introduction. So what is a learning curve? So generally, a learning curve is a plot that shows time or experience on the x-axis and learning or improvement along the time for along the y-axis. So we generally have the time in x-axis and a performance or improvement of what we call the learning along the y-axis. So this plot is generally called as a learning curve. So what is this used for? Let us come to the main part of the question. So the straight answer for that is like learning curves are widely used in machine learning for diagnosing machine learning model performance. So this is what they are generally used for. So what determines is the shape and dynamics of a learning curve can be used to diagnose the behavior of a machine learning model. So there are three common dynamics that you're likely to observe in learning curves that they are like I have attached a picture for that. You could see they are like underfit, overfit, and good fit. So these are the three conditions which we are going to distinguish using this learning curve. So if you observe the first one, which is underfit, that is due to the high bias. The second one is just right. That is what we want. And the third one is like overfit. So that is a high variance. So how do we find that underfit and overfit from the graph? So for first one, say high bias, the learning curve shows high error on both the training and test sets. So the algorithm is suffering from high bias. You could see that from the first picture to the bottom left. So and the next one is the high variance. So this is due to like this learning curve, the learning curve which is on the right bottom, like shows this learning curve shows a large gap between the training and test set errors. So that algorithm is suffering from high variance. So this is the plot between error and the training data set size. But the main part of the question deals with the first picture that I attached, where it is used to distinguish between a very high bias, just right, and high variance that is overfit. So this is my answer for the second question. I'll be discussing the answer for the third question now. So before that, I'll share my screen. So I hope the screen is visible. So the question is describe the process of creating a random forest for classifying spam emails. So before that, so the random forest classifier. So the random forest, like its name implies, consists of a large number of individual decision trees that operate as an ensemble. So the algorithm classify data into different classes using decision trees. So during the training phase of some of the decision trees are created and later used for the classification task. So this works by considering the elected class of individual trees, and the class with the highest number of votes is considered as the final result. So that being said, we'll jump into the question asked, that is like classifying whether the email is spam or not. So for that, the algorithm is pretty similar to what I've shared in the presentation. So the condition is like uh, before the stopping criteria isn't reached. So that is set like B is equal to 1 to capital B, which is the total number of trees. So we'll have to select a self-starting sample K randomly from the training data and create tree Ri from the selected self-starting sample S using the steps that I'm going to say. So the first one is like select P features randomly from the total of a number of features, and preferably like P should be very, very small when compared to the total number of features. So, and then we'll have to calculate the best dividing point for node D among the P features, and then we'll have to divide the parent node to two offspring nodes through the optimal divide, that is like spam or not spam. And then we'll have to repeat the above steps, like the above three steps which I said, not to maximize the number of nodes that is created. So after that, like we'll have to create a forest till the stopping criteria is reached. So once that is done, the loop is ended there. So the output that produces a range of trees which can be used uh, to decide whether it is spam or not. So once it is ready, the next one is making prediction. So as it is said in the uh, presentations, the classification deals with majority voting of all trees. So majority voting of all trees means uh, either it is spam or not. Each email would be voted by any all the trees. So for that, this is a small algorithm, I would say. So we'll have to use a new sample for each created tree starting from the root node. So assign the sample to the class matching the leaf node in that. So then at last we'll have to merge the votes, or what do you call, results of every tree, and the output of the class with highest number of votes will be the answer as it is displayed on the predictions like. So probabilistic voting is what we call there. So the label corresponding to maximum probability is the final histogram. So it gives whether this email is spam or not. So this is my answer for this question. So stop my screen. Thank. Hi, now we will be discussing about question number 4. So before that, I'll share my screen. Oh, I have to share my entire screen for this. So I hope my screen is visible. So the question is, describe how k-means clustering works and the good practices when using k-means clustering. So I would like to take it from the notes. Uh, it helps me better to explain this. So this is what I wanted to like share. So consider k-means clustering. So consider this graph to our right, which contains two different sets. So we confine our k to 2 here, and like we want to cluster them into two clusters. So there are like two clusters. So for that, first we'll have to initialize two centroids at any random locations of our own wish. So we'll just mark those centroids in red and blue in these two places, and then we'll have to go through all the samples and assign them to the closest centroid. So for all the samples, we'll have to assign the whichever points fall to the closest centroid, we'll have to mark them separately. So consider this point. So the shortest distance to this point is this red cross rather than the blue cross. So it has been assigned red, and same with this one, where the distance between the red cross is lower than the distance between that and the blue cross. So here is this belongs to the red, and similarly we have grouped them into a red one and the blue one. So this is what is shown here. So points closer to red centroid are labeled in red, and similarly that with the blue. So the next diagram, here we go with like we'll have to compute the mean for the red and blue clusters here. So this group's mean means the position. So the positions of each and every red divided by the total number of red. Uh, and here for the blue, similarly, we'll have to evaluate the positions for blue and divide by the whole total number of blues. And now we could see the centroid has moved to a new mean position from where it was earlier. So the next one is like we have to compute the new means for red and blue clusters. So now we'll have to consider these clusters. So red and blue, and now we'll have to know their means. So exactly what we have done earlier too. So when we consider the means here, so this would the centroid would further move towards into the cluster, and similarly here. So this is how we'll have to like do the k-means clustering, uh, k-means clustering classification. So now we go into the second part of the question, where what are the good practices when using k-means clustering. So the one is like the main thing is like we'll have to randomly pick k training examples and notifyly like k should be less than m, and like then we'll have to set mu1 to mu k, which are like centroids equal to these k examples. So this is really a good practice in k-means clustering. So this finishes my answer. So I'd like to stop my screen. Um, now we'll discuss about the fifth question. So before that, I have to share my screen. So guess my screen is visible. So the question is, describe 5 operations in convolution neural network and what roles do they play in CNN. So we would like start it from the convolution layer, which marks the first. So this is the first layer, like that is used to extract the various features from the input images. And in this layer, like we perform convolution between the input images and a filter of a particular size, say m cross m or n cross n. So by sliding the filter over the input images, the dot product is taken between the filter and the part of the input image with respect to the size of the filter. So the output is termed as feature map in this, and which gives us information about the images such as corners and edges of this. And this feature map is fed to other layers to learn several other features of the input images. So this marks the first one, convolution layer. So next is the pooling layer. So a convolution layer is mostly followed by a pooling layer. So a pooling layer usually serves as the intermediate layer between the convolution and the next one, that is a fully charged layer. So the main function of this layer is to decrease the size of convolved feature map, thereby to reduce computational cost. This can be done by decreasing the connections between the layers and independently operates on each feature map. So this is what it is, and depending on the method used, there are several types of pooling operations, in fact. So let's say in max pooling, the largest element is taken from the feature map, so that is why we termed it as max pooling. And in average pooling, we calculate the average of the elements in a predefined sized image session like m cross m, n cross n. So, and in sum pooling, the total sum of elements in the predefined section is computed. So this mark my answer for the pooling layer. So next we go into the fully connected layer. Um, so the fully connected layer consists of weights and biases along with the neurons, and is used to connect the neurons between two different layers. So this is what we know, and like these layers are usually placed before the output layer and they usually form the last few layers of the convolution neural network. So the main operation here is the input image from the previous layers of flatten and fed to the fully charged layer. So the flattened vector then undergoes few more fully charged layers where the mathematical functions operations usually take place. So after this, like now we are like now the classification process begins to take place. So that takes us to the next topic, that is the dropout. So usually when all the features are connected to the fully charged layer, fully connected layer, it can cause overfitting in the training data set. So to overcome this problem, a dropout layer is utilized where like a few neurons are dropped from the neural network during the training process, which results in the reduced size of the model. So on pausing a dropout, say like 20%, 30% of the nodes are dropped and randomly from the neural network. So this is what is robot mean, and that takes me to the last part of the answer, that is the activation functions. So the most important parameters of the CNN model is the activation function, I would say, because they are like used to learn and approximate any kind of continuous and complex relationship between variables of the network. So in simple words, it also decides which information of the model should proceed in the forward direction and which one should not at the end of the network. So this is like most important powerful one. So like it can also like adds non-linearity to the network. So it adds non-linearity, and there are like several commonly used activation functions such as like softmax, tanh, and sigmoid functions. So these are the examples of them. So this marks my answer for this fifth question. So I'd like to stop my screen over here. So now we'll be discussing our answer for sixth question. So before that, I'd share my screen. Question. Okay. So the question is explain how residual block works and why does it allow training a deeper network. So I'll go to the first part of the question and directly answer it. So explain how residual block works. So first, the residual block will map A of L to the next layer. So the same layer as linear transformation, and it is like in the same way as like a same layer as linear transformation and add a bias. And then it will have a pre-activation function that is L plus one. And this will also pass through a non-linear function and get the activation for a A of L plus 1. So there's a main one here. So the significance is when we compute the activation for the second layer in the residual block. So when we actually compute the second layer, we add the input to the reactivation before we take the nonlinear activation. So it is useful because the network is like able to skip some of the layers here without much deteriorating in its performance. So that is like a useful thing for about skipping those layers here. And like this marks my answer for the first part. So the second part is, why does it allow training a deeper network? So if we like train a deep network, a plane without the residual block, there'll be like divergence in the training error versus that layer graph. So interior and training will go down, but the test error will go up. So like therefore causing a overfitting, like it fits so good for the data. So for residual network, the graph will keep going down and maybe saturated and does not tend to overfit. So this is why like it allows training a deeper network. So that marks man. Hi, I'll be recording the answer for the seventh question. So before that, I would share my screen. So guess you could see my screen. So yes, so I'll like start it. Uh, the question is explain how a recommender system works and describe the similarity and differences between a recommender system and a supervised classifier. So for that, like going into the how part where how recommender system works, there are like many ways we could make the recommender system. For example, the collaborative filtering, content-based filtering, multi-criteria, recommendation system, etc. So the one which we dealt with the class was the collaborative filtering. So I'd like to explain that. So collaborative filtering is based on the assumption that people who agree in the past will agree in the future. So and that they will like a similar kind of items as they liked in the past. So the system generates recommendations using only information about rating profiles for different users or items by locating peer user items into a users or items with a rating history similar to the current user or item. So they generate recommendations using their neighborhood. So a key advantage of the collaborative filtering approach is that it does not rely on mission analyzable content and therefore it is capable of accurately recommending complex items such as movies without requiring an understanding of the item itself. So, when building a model from a user's behavior, a distinction is often made between explicit and implicit forms of data collection. So, this I would like to put it in a brief thing. So, the examples of explicit data will be like asking users to rate an item on sliding scale on a scale of 5 or 10. So, another one for this is asking a user to rank a collection of items from favorite to least favorite. So these are ways to get explicit data. And the other one, implicit data collection, is like items that users view in an online store and analyzing items are users viewing items. Uh, Viewing times, sorry, like say how many times you're viewing that. So this forms the answer for the first part of the question. So what is that to do with the recommender, sorry, supervised classifier? So as we already said, the supervised classifier like algorithm learn from labeled data where like after understanding the data, the algorithm determines which label should be given to new data by associating pattern to the unlabeled new data. But here the difference is the recommender system need not know about the data itself, but still it can do the a process like it can say give you an answer. So that's the main difference between the supervised classifier and the recommender system. So one example I'd like to give is like this thing, the classification where the classifier predicts the category the data belongs to, like the spam detection and like analysis, some like dog breed detection, so on. But the recommender system understands the likelihood of the user and predicts the value like based on the previously observed data, like say a Netflix movie recommendation or the Amazon's product analysis, like it shows the recommended products you'd like to have. So that's the main difference between those both. And like here I conclude my answers for the recitation too. Okay, thank you.